So hello everybody, thank you for joining us in our webinar today. It has a title, Efficient Test Preparation through Diagnostic Simulation. And you will hear a lot of things about simulation, ECUs, diagnostic communication, and so on and so on. But before we start with the real topic, I would like to do a small introduction round. Not for all of you, that would take too long, just for us. So I'm Ingo Drün. I'm the guy on the left-hand side. My education is an electrical engineer at Technical University of Dortmund. So I'm here working at Softing Automotive as a key account manager, so more than 11 years now. And I'm the sales responsible for the TCS, that is a diagnostic simulation tool. You will hear about this in the next few minutes more and more. Yeah, and that's my, let's say, part. Only an addition, if you want to contact me later on after the show, you can see my email address down there. Okay, that's about me. Dirk, let's talk about you.
Yeah, hello. Also, welcome from my side. My name is Dirk Pavels. I studied and also worked as a computer engineer, project manager here, several tasks here what I have, and now in the last years, I'm technically responsible for our diagnostic simulation solution, especially the new product. It's not really new, it's maybe on the market since 2 years, the Softing TCS, what we will now present. And yeah, later on, I will present you the demonstrations, but now Ingo will continue.
Okay, thank you for that, Dirk. So by the way, if you have some questions, so please use the chat area to ask the questions. We will not answer them immediately, but after the show, we go through all your questions and we'll try to answer them then. Okay, then let's start with the real topic. I like that. So now it works. Okay. So just for the motivation first, what we are talking about and what's the reason for this presentation is, so as said, we will talk about simulation. And before we go into that topic, it's worth to see some things around that. So this is, you know, the most of people will know that. That is the extended V model, which describes the life cycle of an ECU, of a complete car, and so on. And within this life cycle, you see with the blue line, different testers which are needed to test the function of the device under test, the DUT. And that can be one single ECU, or it can be a bunch of ECUs if you have a complete car, for example. So on this testers, you see hills, test bench, road test, production test, and workshop testers. So they are there over the whole entire life cycle. And these testers need to be built up and also need to be tested, right? And a few things these testers have all in common, and that I will show to you now. So we have typical components in such a test system. As you can see there, we have, for example, racks, a PC, an automated system. We have test routines, power supplies, cables, and so on, which we have to build up to a complete test system. And then via an VCI, we connect one or maybe more ECUs as called device under test. And the topic is, normally you can just test these things together. That means the device under test and the test system can be tested only when the device under test is available, physically available. And then you have an effect which you normally wanted to avoid. The thing is that both components come together and both of them maybe have some errors and failures, and then they add these failures. And you have to distinguish, is the failure coming from the device under test, the ECU, or is the failure coming from the test system? And that causes a lot of trouble, let's say, extra work and so on. And this is expensive and time consuming because you have to make a complete analysis phase to bring these things not together, but to separate them. And that is a thing, it's not good. So you want to avoid it. And so the idea is, and that is something where we bring later on our solution into the game, is you would like to have a solution where the executive test can be done with an already released tester. That means it would be nice if you have a tester complete ready. And then later the device under test comes into the game. So not everything together. That sounds a little bit strange. How we can do that? Do we need a time machine for that? Of course not. So it's not magic, it's just engineering. So stay with us for the next 20 minutes and then you will hear about more about this secret. Little spoiler, it has something to do with ODX. So the simulation comes into the game to solve that problem. And as you can see, the simulation of the device on the test is this box under there, right on the right-hand side. And so let's concentrate a little bit about this box, because with this box you have a perfect front loading, what you can use there, and at the end of the day, it allows you valuable tests to make. That is the goal of all this. Okay, so let's concentrate on the box and the system around. So the complete simulation, the softing TCS, has some more building blocks to offer. So that means you see the box over there, the silver box, but there are some additional components, software components, which run on a PC. They are called TCS admin, TCS operator, or TCS test bench. And the box itself, it also has a name. It's called TCS device. And how does that work? So we have different simulation files. So the simulation files are stored on the PC, and also the administration of the different simulation files is done on the PC. And depending on your needs, you send down a simulation file to the TCS via data interface, and then this TCS can play the role of an ECU or more than one ECU, for example. It depends on what you say to the TCS. It can be an ECU of the powertrain, for example. It can be a ECU of the brake system. Whatever you need, you code it in a simulation file, send it down to the TCS, and TCS takes over that role. So that is the idea behind all this TCS system. And to follow that up, we go through, because it's worth to see how is it about simulation, what kind of simulation we are talking about, and what has to be simulated, right? And so we go down a little bit deeper to diagnostic communication. Diagnostic communication is the game a test system plays with the device under test, or in this case, with the simulation, with the TCS. There are a lot of rules defined how this works. The typical request and response is going like this. Test system sends something out, that request, and the response comes back from the TCS device. That follows some rules. So we have some normal communication working in here. Of course, we can have some repetition or some things like don't care. That means the request is sent, but no response is awaited. That's also fine. But then, of course, we have a big bunch of errors. So that means something is sent, is not responded, but response is awaited, and things like that. Or there is a timeout. And all that things are the typical diagnostic communication between the test system and the TCS or the ECU. And the TCS, of course, has to simulate all that ECU behaviors so that the test system recognizes it as an ECU. All right. Sounds complicated, but it isn't. And to show you how that really works, now Dirk will open up the GUI from the TCS and show it like it really works. Hey, have fun.
So, yeah, then you should see now the application. It is the TCS admin responsible for the administration and configuration of the simulation files. Simulation file, principally, it's an XML-based ASCII file. And in this file, there's a definition of all the requests and responses, what Ingo showed to you before. Here with the application, I will show you now the content of the simulation in a better way, because now we have here a UI where you can see very clearly First, on the left side, the ECUs. So here on the left side, you'll see all the ECUs, or more precisely, there are the ECU base variants, and each base variant can contain ECU variants. So base variants are marked here in black color, and the ECU variants are here in the blue color. So then you can decide each variant can base on CAN communication or on a DOIP communication. Here, in contrast to other diagnostic simulation solutions, we have here a real communication on CAN or Ethernet or both together. And so then you should also, so here we should also allow the manipulation of the communication parameters. I show you the first tab on the right side. Here you can see all the responsible communication parameters, which are based on for these variants, base variants and ECU variants. The first two groups, we have the CAN communication parameters. We have the CAN1 channel. It's pinned on the OBD connector of the device. And then we have a second CAN. It's on the besides there we have a D9 connector. Can then switch directly to the second CAN channel. And we have then on Ethernet the diagnostics over IP communication. Here you can see all the gateways. Each gateway can contain a specific IP address. You can see them here in the I suspect ISO 300/400, 3400.2. You can see this is here's the IP address, and for the next gateway, we have then the IP address .3, for example. Here you can see it, and you can manipulate all the communication parameters like the logic address, the gateway, but also, of course, the ECU specific parameters for CAN. Maybe you know the CAN identifiers. If I switch to the specific ECU, then you can see here on the right side. On the right side, you can see the CAN identifier. So next thing, of course, we need simulation behavior. We need the services. So for each request which comes from the tester system, we can define a response. How shall the device react to the request? So you can define a simple response, what you see here on the response column. And you can see that you can define just the PU. You can also define some variables. For example, if you want to realize the session handling, then you are able to do it here with the TCS device. So that means if the tester activates the extended session, then we see it here in the response, and we switch the variable to the value 3. And now we get read data by identifier service. Then in reaction to or in dependent on the value of the session variable, we would send then a positive response or a negative response. Here maybe you see the tooltip. If the session is has the value 3, that means extended session, we would send the positive response, or if we are not in the extended session, the tester would get a negative response here. This is one use case. Several more use cases what you can use. For example, simple coding you can realize. So that means if the tester try to code the device, then we have here some definitions. Maybe not here. Here you can see we have the variables on the request side. That means if the tester tries to recode, then the device checks the content of the request and puts the content of this value into the variable. And then the tester checks the coding. That means if the tester sends a read data by identifier service, then you can see the same variable on the response side. That means the content of the variable would be put into the response. And then the tester thinks, yes, this is a codable device, and the coding action was successful. So then, of course, you have also possibility to see all the variables, including the start values, because the simulation must start with a defined behavior. So we have to give a start value for every variable. And then we have the function table. I would present it later in the next demonstration. But here, for the first view, you can see that you can manipulate all the services, all the communication parameter for each variant here on the left side. If I select the base variant, for example, ECMA-DOIP, then you can see the belonging services on the right side. So and all the content, what you can see here, it's embedded in one simulation file. And now later on, I have the possibility to put the simulation file to the TCS device. I could upload the file to the device and start directly the simulation. Maybe you see it here in the status bar. We have already started the simulation in the device. So it's already started on CANs 2 and on the UDP and TCP stack. And we have here a running simulation, what we could stop it here and maybe start another simulation. So maybe this was the first overview, and Ingo can continue the presentation.
Okido. Thanks a lot so far, Dirk. So I will take over again with the presentation and continue there where we stopped. Okay, that was the first demo about the first basic simulations, which we can do with the softing TCS. Let's continue then with the next step. So what you would like to do, of course, is that we would like to extend this portfolio, so to say, because there are so many more things to do with simulations. For example, we need variants of ECUs and vehicles. And to handle these variants and vehicles, we need from time to time simulations. They are based on ODX specifications. That is a thing that really helps you. The ODX describing function is a special describing format where you put all the requirements in, and all these ODX specifications can then be read. And from out of this ODX specification, you can make a simulation file. So Dirk explained a little bit about simulation files because they are needed for the TCS to play as a ECU. And so you can take here the ODX specification, which is already, let's say, done by other persons. And you can take this, make a simulation file out of this. TCS has the capability to do that. And then you can handle ECUs, variants, and even all vehicles. There are more than two benefits I hear. The first is ODX file is already done. So you, as a user from the TCS, don't have to be a super programmer to use this ODX file to make a simulation file out of this. That means even if you are not so familiar with diagnostic communication, you can use that here and just execute. That is one thing. The next thing is the ODX file itself is earlier available than the real ECU. I make an example. So the ODX file, because it's a part of the development of an ECU. So the ODX file is, let's say, available on the 1st of March and the real ECU on the 1st of June. And so we had this dilemma in the beginning of the presentation, how to make that the tester is available, completely tested, and then the device on the test comes later. So with the help of the ODX files, you can solve that problem. You got the ODX files, you can test with the ODX files. You have then some weeks, in this case, you have 3 or 4 months time. And then later on, the real device under test, the ECU comes, and the tester is already tested. All the failures from the testers are, let's say, solved. So that makes the thing much, much easier, and you save a lot of time, and you can rise up the quality of the whole process. So ODX is a really big thing in this case. Another topic is here, you can see, as said, the vehicles, ECU and ECU variants are all, let's say, coded in this ODX specification. And as said, you have a simple creation and adaptation of simulation. So you can use it even to be not a big super programmer. Another thing is we have to extend a little bit the use of diagnostic communication. So far, we had a diagnostic communication being very static. Request, response, and so on. So that means the values are more or less always the same because there is nothing dynamic in. But we have to have dynamic impulses because in the real world, especially if you are dealing with engines, for example, a lot of times things are rotating like wheels or some wheels internal in the machine. And if you have some values which are taken by some sensors, then you have dynamic values. So that means they are changing over the time. You can see that in here. You have a function, and depending on the function and the time, the values are changing. And that is something that you want to have also in the TCS, to have real communication, not only the static one, but the dynamic one as well. And after that, let's say, step, then the diagnostic communication is more or less complete. Then you have a complete simulation of both topics. And of course, TCS is capable to do that, to handle these both aspects, this static one and the dynamic one. And to show you how that works, the variables for the diagnostic session handling, we have a second demo phase. That means the ODX-based creation, Dirk will show you in a minute, and of course the things with the dynamic values. Okay, Dirk.
Thank you, Ingo. Okay, then I will share again my screen. Now you should see also the TCS admin again. Yes, I will show you the functions, the mathematical functions. So I reopen the softing demo, which you already saw it before. And now I switch to the tab functions. Here we have ECU variant, which is using the functions, the function concept. So instead of a fixed variable, maybe I will show you the first way. I go to the diagnostic services. Here you can see there are the variables. That means we have a fixed value dependent of the content of the variable. Maybe later on you can change the value of the variable. If you go to the variables tab, then the software allows you to change the value of the variable. It's very useful if you try out your different sensor values, 20 degrees, 22 degrees. So if you want to work on the ODX way, and then you want to see how it would, what is the tester system is showing you on this side. So this is one way. So using the variable and changing the values during simulation. And then we have the way to of time-dependent functions. It means here we have again on the diagnostic service. You see the violet marked services. Here we are using the mathematical functions. You can see just the name. This is the name of the function. And if you switch to the functions tab, then you can see on the left side the names. You can see the initial value, but more important, you can see here the formula. You can define some formulas. Maybe you can define a sinus or a cosine, a sawtooth, a triangle, or also some linear functions, what you can see here. But here you are free in defining the functions. And if you don't know really how it could display, you can see here a preview. Here you can see the linear function, or you can see the sawtooth. This is the preview for the first 10 seconds. Maybe you can see in 31 seconds. You can see here, then you can see the 3 periods, how it would act. And on the left, on the y-axis, you can see it that the curve is going from 10 to 130. The software allows you for defining it on a very easy way. Here you can define the function, a sign, so you can define the period time, the phase shift, minimum, maximum value. Later on, we will also support ODX. It will come the next version. Then we would support not only the PDUs, but then also the ODX, the symbolic values. So we are implementing for this topic. Yes, and if you have defined the functions, then maybe you can, yes, I can switch to a tester system. We have here DTS9 as a tester. I would switch to a workspace which has defined some diagrams. Maybe we can first look for the communication. We have to start the communication. I can start the communication on the CAN. Here, the downside, you can see that there are some responses coming from our device. And if I go now to tab, which is showing us a diagram, I can start the measurements. And now we can see here, I have 3 measurements like vehicle speed, RPM or engine of level. And you can see the curves. You can see this is a sine curve and a sawtooth. This is coming from the device. On the right side, on the bus monitor, you can see this is a real communication, not only simulation, not software simulation. It's a real communication on CAN on this example. And now I would come to the ODX. Yeah, how you can get the data. Here's this very time-consuming to define all the functions and the services. So we have a very easy way to transfer the diagnostic services from ODX to simulation data. So maybe first I close. I want to show you DC's admin. I close the softing demo, and then I can create an ODX project. So first, we have ODX containers, PDX container, or something else. I would try to import these ODX containers. Here you can see there are some exemplary variants, ODXD and ODX C files. I would select all of them, and then I go to next. I would give the project a name. For example, I give a demo. I can keep all the default settings. I type enter. Now there are no error messages. I go to complete, and now we have an ODX project. And in the second step, now we can create a simulation based on this ODX project. So therefore, I press here create simulation from ODX. I would choose my freshly created ODX project with the belonging vehicle information table. So I can choose also another vehicle information table if the project has it. And now I can choose one or more variants. I would choose here one variant, ECU variant for the engine control module. I confirm it by pressing OK. And now you can see on the first, we have now the communication parameters suitable now for the ECU variant. You can see these are the CAN identifiers for an engine control module, 7E0 and 7E8 for the response. And also we have responses for diagnostic based on the ODX services. So yeah, it looks not so bad. If I go to, for example, to the response of the diagnostic session control, you could also manipulate the values on the ODX way. So you can see here also already some useful values. That means I could now change the values on the ODX way. So I can type 3 seconds for the last parameters, and there's automatic calculation to an PDU. Maybe you see it here in the top. the PDU, there's already a valid PDU. So you don't have to know the exact calculation, or you don't have to know the PDU. You just enter a time value or a degree or what else. You can manipulate the ODX data. You can press OK, and now you have the changed PDU here on the response side. You can do it with every response. You can change the symbolic data. And as you see, we had already some values. This is the reason because I preset some values. If I go to the settings page, tab ODX, then I already predefined some parameters, some response parameters. So you can here define the short name of the parameters. You can define the symbolic value. Maybe I can just give a location in which area it should look for this value. It's much better to predefine the values in advance than later on, because maybe you want to make a simulation based on several variants, and they have all the similar values. And then you should do it before. Of course, you can do it also afterwards, but yeah, for some values it's better to do it before. Here you can also make some other settings. Here I concentrate on specific service identifiers. So now we have just simulation for these service identifiers. You can do it also on the other way. You can ignore specific service identifiers. You can also use variables for the coding way, for the measurement. You can use functions. So here you can really save time if you do it. You can define the wished response type. You can also say, oh, I want to start with the negative responses, or I don't want to have responses for each request. Maybe you want to define the response later on, or you want to see what happens with my tester if the ECU does not respond. You can define the numeric value limit. You can define the lower upper limit, or you can give 2 responses for each request. So the first response with the minimum value, and the second response with the maximum value. So you are very free to define some settings. And so as a result, you have now here a simulation which is ready. You could now upload this simulation to the device, and you can start with your simulation and start with your tester systems activities. So this, I hope it was not so fast, but yeah, you have the possibility to ask us via the chat. But now I think Ingo can continue.
Okay, thanks a lot. So I will share my screen again. Okay, that was demo number 2, right? So we continue. So we have seen the TCS is a really powerful tool. So what you would like to add now to make the picture complete are some additional use cases. So the use case number 1, which you would like to mention, is the regression test of a tester. So the idea is you have a lot of, let's say, different vehicle types, lot of model years and variants per vehicle type. So this is a bunch of ECUs, a bunch of data, and you have to handle this. And of course, there is an expensive possibility. You have a garage with 50 places where you put 50 cars in, let's say, and every time you need something, you take one of the cars out and you make your tests and send it back. This is the expensive version. Of course, nobody will do that. So it's much, much easier if you take one of these cars where you know you will need it, and then you just record the diagnostic communication between the tester and the car and the ECU in the cars. And with these records, you build up some trace files, so to say, just with the recording of the diagnostic communication. And with these trace files, you are able to make, again, simulation files for the TCS. So this is really simple. You just record the diagnostic communication, and then later on you have a simulation file. And that makes it happen that you have, let's say, 500 cars with 100 variants just on your PC, not space consuming, not time consuming. That's really, really easy. And with a test bench, that is the software component in the TCS, which is running on the PC, you also can have a communication and an interface to the test automation systems. And then the system is also testing on its own. So you don't have to do too much to this. No? And that is a big advantage where you can use the TCS and save, as said, a lot of time and space. You can sell these cars better to somebody else and take the money. That is use case number one, additional use case. Another one is called tester training and tester support. So the first tester training use case is an education use case. Imagine you have some students, you are in university or you are an education center from an OEM, and you want to give the possibility to play with ECUs and diagnostic communication and so on. And of course, you are a little bit afraid because if you have cars there and these pupils or students are not really familiar because they are beginners, you don't want to damage the ECUs, because if they are damaged, then you have to, what to do? Take them out, bring news in and so on. So a little bit afraid. So it's much, much more simple to use a TCS with a simulation file on. And if something happens and the simulation file maybe is gone, then you just copy, send it again, and it works. So no damage, no problem, no time consuming things. So this is the education use case where you can use the tester together with the TCS. And the next thing is the support challenge. Imagine you have an ECU that has some failure and somebody is sitting somewhere on the planet and tries to find a solution. And he says, okay, I need help from other persons. But you just have this one ECU. How you can send that around? Okay, you could do that, very time consuming, and you can just send it to person number one, 4 weeks later to person number 2, and so on. That's not the way it should be. So if you have, let's say, the simulation file already on your PC, then you can, of course, send the simulation file via email or you put it on a server. And your colleague, let's say in another country, he is also in TCS, he can take the simulation file and then you can work both together on the same problem with the simulated ECU and can find a solution. And this sending around the ECUs is really used in the industry already. And we have an answer here from a customer who has done that. No? We have solved a problem within a day where we needed normally weeks. So that means that is really a benefit where you can see that the TCS takes a lot of work away from you. It helps you in the daily work to solve top problems with simulation files. That are additional use cases that we just wanted to mention. Or I have to speed a little bit up because we want to also to answer your questions. So just the thing, why are you using diagnostic simulation? So we try to bring that in a graphical way. So we have the time and the effort, and we have the case without the simulated diagnostic device under test, and of course with using TCS. So start with the normal DUT without a TCS. You see, you have a test case development phase with some effort, of course, and then the test execution comes. That was a dilemma which I explained in the very first beginning of the presentation. Both failures come together. Is it the tester or is it the device under test? And then, of course, after some time, you reduce the failure rate and then it goes down to 0 and then the thing is done. That's possibility number 2. If you take the TCS, you may have a little bit more effort for the simulation creation, but most of the time it's done automatically. You put a file, trace file, ODX file into the TCS, and it's automatically generating the simulation files out of this. And with this effect that you are earlier, you know, ODX time machine things, you are able to do your tests before the device under test is there. So the test is already finished. And then if the device under test comes, then it's easier to test. So that means the effort in total is much, much lower because this confusion effect is not there. And you see that in comparison to each other, you see you can have a lot of time saving using the softing TCS. And of course, you have a lot of savings using in the effort way. So both times you win using a softing TCS. That's the point. So just to wrap up at a glance, the use case specific way to create simulations quickly are, for example, ODX-based. We have seen that. Dirk showed that to you. You can do it via trace import, or you can even do it manually, request response bit by bit. In total, you have time and cost savings due to the clear assignment of test errors. Is it from the device under test, or is it from the tester itself? And of course, you have quality increasement due to earlier start of testing. That are the main, let's say, positive points of a softing TCS. And that's it, what we wanted to show to you. So thanks a lot for your attention. And now, of course, we would switch over to the question and answers. So now we go to the different channels and have a look. Maybe Dirk, you can just start with this. So have a look to the chat channel, and then we go through the questions and we'll answer them. If you have questions after the show, we again put our email addresses here, Ingo Drüen@softing.com and Dirk Pavels @softing.com, so that you can contact us after or tomorrow, the day after, as ever you want. Okay, so I will leave now the presentation mode and then we go to the different questions in the chat.
I have a first questions. I repeat these questions. Talking about vehicles, does this mean passengers car or trucks or even both? Yes, we didn't speak about this. So maybe you saw the label on the TCS device. We support 12 volts power supply. That means it's a 12 volts also connected to the OBD connector. That means the VCI normally takes also the power from the car, normally from battery inside the car. Here we have delivered power supply 12 volts. So this is normally okay for normal cars. But yes, we also support the power supply for trucks. 24 volts will be also supported. But here we have to take care about the VCI. That means if you have a power supply of 24 volts and you would connect it with a 12 volt VCI, which is only for 12 volts, and maybe you can destroy it. So you have to take care. But next time we will also support the Ethernet activation function. That means now we have a DOIP communication which starts directly after starting the simulation. And if we have now then the signal condition, then we have the Ethernet activation starting with the signal of the tester, Ethernet activation, and then we will start the simulation. So that this you will get also in future the signal condition from us. But this is just an adapter which you put on the device. Oh, thank you for this question. Okay, I see one more question right? in the questions section. What additional features do you have on your to-do list for future releases? Yeah, we have a defined roadmap for at least for this year. So we want to get more the ODX way. That means that we support the manipulating the data on the ODX way. And here in the next version, the late summer, you will get this version for ODX. Additionally, we will, of course, also try to do more simplifications for the data. We want to also, we had a possibility that we can trace all the flash data, the flash traces. We had some problems with monitoring of very large frames. This will also come in the next time. But normally we are open for some feedback. Also, I didn't mention the encrypted communication, the TLS on the DOIP. We are also already realized this. And so still we have to do maybe more improvements on this way. Then we have next questions. We have variables and functions to manipulate in TCS to create simulation files. Why we can't export it to SPAR files or other ESC files as a means to other simulation formats. The SPAR file, this was a predecessor of our XIM file. This is from our HSX files. So yeah, in future we just want to support the XIM file. So that means we don't have export for SPAR file. Of course, it would be possible, but we want to do another way, that we just want to have the XIM file as a standard. And but for this point, we can of course discuss how to. I understand that maybe here, I think this customer is using many old simulation formats as the SPAR files, and here I can understand that you don't that you just also want to use the old simulation devices, which are just use this format. But maybe we can find a way. We can discuss it later on. Okay. So I switch to the chat. Here.
Yes, just I see we're a little bit over the time. So maybe the last question that you could answer, Dirk, and then I think we can close the session maybe, no? Okay.
Okay. Here I have a question. Do we have an automated fold injection and a system response list from each fold injection? Does this require a complete SFMEA to compare simulation results, expected results, or we can just have what change in the system? So yeah, we just support the ODX way. So maybe if you have the specification and an ODX, then this way we can support. Otherwise, if you have a specification, maybe in a text format, what we could import, of course, and it's also possible. Yeah, so normally, many customers from us are using the ODX way. So this was a way, the reason why we concentrate now on the ODX. So it would be good also if you have a specification on ODX, and you don't have a problem with this. What software stacks, maybe the last question, what I see here, what software stacks and standards does it rely on? Maybe you saw the ISO specs. We have the standard automotive specifications like Diagnostics on CAN, Diagnostics on IP. We have the UDS, but you are free to define your own answers. But we rely really on the ISO specifications. So if you have further questions, of course you can send us an email. You can you know our email addresses, and then we can of course answer it later on.
Right. Okay. So then, thanks again for your participation, and we hope you enjoyed our show. And as said, send us an email if you have some questions. And so we just want to wish you a good day then, and hope to see you soon. Thanks again for participation.
Okay.
Bye-bye.
Thank you. Thank you for interest. Bye.